Hi there, welcome back to the breadboard and Happy New Year for 2017. So got a little bit of a backlog of mail and things like that. So we're going to start off the year with two mailbags. One for the packages that have been kindly sent to me from RS Components, which are pretty much all of the things just here. And then we've got a whole bunch of other packages which are behind me and things from other vendors around the world that have sent me stuff to have a look at and review and use for my projects. So let's not waste any more time and let's get into the RS goodies. Some of it is quite interesting, and we'll see what it is as we go through, and they're going to lead into a bunch of interesting projects in the first half of 2017. As you can see here, there is quite a stack. Now I'm going to clear away a few of these things to make a bit of room, and then we'll start working through them to see what we've got. Now a lot of them have come directly from the manufacturers, like these two here, rather than going into RS Components and then back out to me. So let's have a look at these ones first and work our way through. So this first package is actually from a company called Barth Electronik in Germany. So this first one is industrial PLCs for automotive and industrial situations. What we have in here are mini SPS STG580 and an STG680. These are industrial controllers, but the nice thing about these is that they are very small footprint, basically hermetically sealed. There's the STG580 casing. I've got two of those, so I'll just put one of them aside. And I have two STG680s, which is this one and I believe that one. So I'll just put those two aside. And we've seen STGs before. About a year ago, I had one of their small units to have a review of, along with a lot of other people, and it was actually physically bigger than this. This is the STG 580. And as you can see, it's quite a small unit. Now what makes this unique is that one, it's completely potted, same as the previous versions that we've seen. But secondly, this one actually has the capability of Modbus as well through RS485. So you've got your standard inputs and outputs along the top here, which support things like PWM. You've got counter inputs. You can configure analog in as well as standard outputs, and we'll look at the specifications when we start doing the actual reviews and having a play with these. But what is different for this one that was not on the previous versions that I've reviewed is, as I said, RS485 Modbus communications, and it's also got a TTL RS232 interface for programming. So if you use an FTDI adapter or something like that, you can plug it into here to program. And I also have the STG680, which, let me just open this one up. And this is effectively the big brother of the STG580. As you can see, this is the 680 here. Twice as much I/O. Still got the Modbus interfacing and the TTL for programming and everything else, but a lot more I/O. So functionally, they're basically the same kind of unit. We'll look at more detail of the specs, as I say, when we do the review. So I've got two of each of these. And really nice thing as well with these is that they can work on anything from about 9 through to 24 volts DC on here. And you can pretty much mount them anywhere, whether and they're not expensive either. So that's the first two Barth units that I have. In this next box here, we have another package from Barth. And this one is a product that has not even been released yet from Barth into the market. And this is an STG 800. Now, what makes this one unique from these other ones is that this is actually a ARM processor inside. Now, it looks very much like the STG 580, except that this one has the ISP programming, so that you can actually program directly to the CPU that's in here. Has the same kind of spec for I/O, and you've got the power and you've got the channel CAN bus interfacing. So the ones we just looked at with the 580 and the 680, they have Modbus interfaces, basically an RS485 interface. This one has CAN bus interfacing, so more suitable for automotive and a whole bunch of other different applications compared to the other one. It just shows the quite extensive range that Barth has in these devices. So I look forward to playing with this one as well. Now the other part that makes this one unique compared to other Barth devices is that you can program this using their IDE, or you can actually program it using a development environment in C++ or C or something like that, and upload the applications directly to it. And as I said, it's got an ARM processor. It runs much faster than the previous units, and therefore you can open up, because you can put your effectively open source to your code, not just having standard off-the-shelf industrial design tools, but opens itself up to being able to develop unique applications to drive the unit as well. So for now, this is just the Mailbag, so I'm not going to go into too much more details about it. This is not yet released, as I said, but it will be done probably by February time, something like that. As soon as it is, I'll provide a link to where you can buy this, but I look forward to actually having a play with it. Now, what Barth has also sent me is the ST-Link V2 ISOL. This is so that you can actually program the unit, because as I showed you, it's got an ISP header as well as the standard RS-232 for programming. And so if you're using your C++, and I think it uses Kyle for the development IDE, then you need to be able to upload to the ISP port using a proper programmer, the same as you would with a PIC kit and things like that. So this comes with a little programming unit with a header that can plug straight into the PLC, and it's got a USB port to connect into your computer. So I look forward to seeing what the capabilities are and how much faster and more flexible we'll be able to do applications using these Barth controllers. Next up, I have some, again, from RS Components. You've seen a few videos I've done recently on the engineering samples of an IoT 2020. So now what I have is, I actually have production versions. These still say engineering samples, but they are actually production level hardware in these. So I'll be looking forward to migrating some of my test applications and using these as gateway devices in some of our bigger units. Now, technically these should also be able to talk to the Barth components too. So a lot of the things that I've got delivered from RS Components will come together in a bigger demonstration project to show some home automation, motion control and things like that. So I look forward to seeing that. Okay, next up, one of the devices that I first reviewed with RS Components quite a long time ago was a 4.3 inch Panel Pilot Ace display, basically an HMI from Lascar Electronics. Now recently they've come out with a new one, and what I have in here is a sample of the new display, and this one is actually a full-blown 7-inch Panel Pilot, and it's completely, well, it looks like it's completely redesigned, and I'm basing that on the fact that this is the back of the unit, how thin this is. It's still an industrial grade display where it's going to be splash proof and things from the front once you've mounted it into an appropriate chassis. We've got the 7-inch diagonal display, which is becoming a fairly common display size to use for some embedded systems and things. But on the back, what's improved on this compared to the 4.3 inch ones we had a long time ago is there are some additional interfaces on here right off the bat. So it looks like we have a serial port, we have the general I/O connections, we've got a USB connection, but now we have a full-blown Ethernet connection as well, and we have some screw terminals right on here for analog inputs and an RS485 connection. Now I don't know yet what how much of everything has been enabled already, but I look forward to having a look at this and programming up some new displays. Obviously, if going to 7-inch from 4.3 inch, we're going to be able to get a lot more control and usability out of this display. So I look forward to having a look at that. And again, it comes with, on the back here, it's got a rubber gasket, comes with a USB cable and some mounting brackets to help you put it into a chassis. So with the rubber gasket around the panel, it allows it to be waterproof and give you that extra industrial environmental protection if you use it in some kind of hazardous, well, I wouldn't say hazardous, but nasty environments, maybe in a factory or something like that. So that's the Panel Pilot Ace. So next up from RS Components is a package that came from Phoenix Contact. They're one of the vendors that sells through RS. They do sell from a number of other places as well, but particularly this is from my relationship with RS Components that they have sent this. Now I have two things in here to show you. The first one is this bigger one, which I'm going to just pull out now. This is a Quint 4-PS power supply. It's a 24 volts DC power supply at 10 amps. Now, if you've been following along with my industrial control videos, you'll realize that a lot of industrial systems use 24 volts for their power supplies, and this is no exception. This is a 24 volt 10 amp power unit. It's built like a brick, you know what, very, very sturdy. Bit smaller than the previous ones, and we're going to do a video of this, and I'll see if I can take it apart slightly to let you see what's inside. What distinguishes this power supply from other ones is this little thing here. We've already seen some units that I've shown you from Schneider, which are relays that have NFC communications on them so that you can configure the relay. Now this is a power supply that also has NFC built in that allows you to configure the power supply's operating modes. So you can see here there are some buttons and some indicators and some connections here for your signaling, and you can change the voltage output. It's normally 24 volt power supply, but you can actually increase that to 29.5 volts. You can also set some tripping for things like overload and stuff like that. With a power supply, sometimes when you turn on loads, they might spike very quickly at over the rating of the power supply, but then very quickly settle down. You wouldn't necessarily want to trip your power supply out if it was doing that. This power supply allows you to configure the operating parameters so that it will allow you this surge, for want of a better statement, and then not trip itself, or you can configure it to trip immediately if you exceed the 10 amp ratings. You can also vary the output, like I said, up to 29.5 volts. One of the reasons for that would be potentially maybe some longer cable runs between the power supply and the load, and you're compensating for voltage drop along the wiring, as an example. What else is in the Phoenix box here is quite interesting to those of you that have Raspberry Pis, and it's still with the industrial bend to the things that I do, and that is, it is a Raspberry Pi DIN rail mountable case. Now I've just dropped a Raspberry Pi on here so that you can see, but what it is you've got the case comes in two halves. This is the bottom with your DIN rail mount springs and things, and you've got the top half with a little accessible lid that will clamp down over this once you've got it ready to be assembled. Your Raspberry Pi, and it comes with these little rails, clips onto a couple of rails here, and then it would sit normally in the case sideways like this, and then the lid would clamp down on top. Now I'm just going to turn this upside down so that you can see how it fits a little better. So if I tip this upside down and just put it on the mounting rails, alright, so it clips in there, so you've got full access to the normal outputs and the Ethernet, the USB, and on the side here you've got access to the USB power, HDMI output, and composite video audio output, and that would be made accessible through the hole on the end, as you can see there when it closes together here. You can bring those cables out if you're using them. Now the other thing with this as well, which I haven't shown you yet, is you can get a proto board that goes with it, which will actually sit on top of the Raspberry Pi once it's plugged in. We just drop that on top. So it's sit on here like this, and that would actually be accessible on the back edge here. Right, there's some connections here which are part of the proto board, and they actually become exposed when you clip it in along this slot here. And you actually get some, let me just try and find them, headers that you can solder in, which then have plugs that allow you to connect wires up to bring control signals from maybe opto-isolators or relays or whatever you might want to put onto this daughter board, so that your Raspberry Pi can actually become effectively an edge device or a local monitoring device for some IoT application or something else, home automation, with ease. So you've got the proto board there that you can put on top, bring out these connections. So there's 4 of them as standard for this case. And this case is available, as I said, from Phoenix as well. You get other items that are available, things like standoff headers and things, so that you can extend it, as I said, to other cases. So very, very useful for a Raspberry Pi mounting, to very quickly take it from being a standalone Raspberry Pi, which, when you want to mount that and use it, what do? Well, this gives you a nice, easy solution. So the last box from RS Components is kind of an update from some of the industrial control things that we've been doing over the last little while. And one of the things that I've been trying to do is a CNC machine, and I've just started building up a new version of the CNC. It's actually in the other part of the room here, which is half the size, half the width, half the length of my previous CNC machine with twice the resolution. And RS Components have been kind enough to supply a bunch of the electronics for that, which I've already shown you in a previous video. But I had a few things that were kind of missing from it that I wanted to add, things like, for cable management and stuff like that. So some of those parts had already arrived and I've shown you them. The rest have now arrived. The other part of what I have in here are some parts that I've been working with RS Components to kind of put together a kit list to go with these IoT 2020. So this is a DIN rail mount, as you already know. It's a DIN rail mount device that will run happily on 24 volts. But what do you do for your 24 volts? How do you get your network connection to it? What kind of things can you plug into the header? In fact, I'll leave this out because we'll have a look at this with some of these pieces in a moment. So let's see what I've got from RS. So the first thing in here, which is going to be useful, are some Arduino prototyping boards. This one is for an Arduino Mega, so that's no good for anything that we're going to put in here. But the other one is for an Arduino Uno. So this shield, if I build up maybe some relays or something like that on here, we should be able to just plug that right into the shield on this. And actually, let me just open it up if I can find a screwdriver. Never a screwdriver when you want one. Guess we should be able to do this. So much for my pencil. So as you can see in here, let me just take these lids off. We have the standard Arduino R3 header in here. So technically you should be able to take any, mostly any Arduino shield, plug it in here and run your sketch, and it should be able to work. So that's why RS have sent me some proto boards so that we can do some things of our own. But what they've also sent me, not that one, is an Arduino relay shield. So this is something that should be able to plug in the top of here. So let's just open it up and see. Even if it doesn't, these will still be useful for other projects where we're using an Arduino Uno or something like that, or a Yun. So this is 4 relays. It's also got some, by the look of it, it's got the 4 relays outputs. It's also got some additional outputs here. So we'll look at the specs of this in just a moment. It's actually got a nice little plastic and insulated cover on the bottom too, which is rather unique. So the I/O is available here but it's all, the bottom of this thing is fully protected, which is kind of nice. Made in Italy. This is an official Arduino relay board. So this one should be able to plug right into here if we're lucky. So which way was it go? This way. Take the plastic bottom off of it and see if it plugs in. And there we go. So that will plug in there nicely. Now your relay contacts come out the side, so you wouldn't be able to put the lid back on easily. You could run your cable out and round and out this end and leave this part of the lid off. I don't know if this will actually go back on. Oh, it will. Just, yep. You can still click that lid over the relay, but of course you can't use the other contacts then. But the nice thing is it will plug into the case here so that you can use it for your projects and things, run Arduino sketches even on the IoT 2020. So that's rather good. That's the relay board. And let me just pull this out again. That's that one. Now the other board I have in here is this one. This one is actually a motor shield. I want to do a couple of projects where we're going to drive some stepper motors or something like that. So let's just get this open if I can. So this one is the official Arduino motor shield. So what we have here is something obviously the same form factor. A nice piece of conductive foam on the bottom again to protect it. And this is using an STL298P controller. Again, a bunch of additional headers on here for, I don't know if they're for the motors and things. Certainly the motors will be connected over here. So this, you should be able to drive a stepper motor with this one because you've got your your motor outputs over here, diode protections for the controller, and I'd have to check with the schematics for this to see what else these other connections are for. It looks like we have 2-wire and analogs and digital I/O also available via these headers, which is very handy. Anyway, so that's the second shield, and again it's capable of just simply dropping right into here nicely. Yep, straight on there, and it'll fit nicely. Cables in this case could come out the side here and you could have a cover over it. Of course, if you put a display or something else on top of that, you would just leave the cover off. The IoT 2020s are specifically designed for a gateway device, but there's nothing to stop you using them as an edge or to run Arduino sketches and things like that when you have them hooked up with this kind of device. As I say, they're aimed at educational market, and therefore you can pretty much do what you like with them, but they are certified as a IoT gateway, and that's where the Linux side of things would come in. But if you have some local controlling a couple of motors for fans or something like that, or monitoring other things via I2C or SPI and things, then you have all of your signals here on the headers so that you can actually put a little local piece of hardware on there too. So that's the Arduino motor shield, which we will also have a look at using with the IoT 2020 as well as other devices. What else do I have in here? Again, along the theme of having devices starter kit for the IoT 2020, we have a here we go, power supply. Now this is, I went through with the RS catalog with RS components to look at what things would be useful for a student or engineer or something wanting to get started with the IoT 2020. And one of the things we identified was a power supply. This is the just plug it in the wall kind of brick, and it comes with a whole host of connectors that allow you to customize it to your region. So the power supply itself will work on anything from about 80 volts, what does it say? 100 volts up to 240 volts. So it's going to work in Europe, it's going to work in North America, it's going to work pretty much anywhere. So in order to adapt the power adapter to the input of the IoT 2020, which is a pair of wires here, we've identified these, which are just simple barrel connectors to 2 pins, and with a couple of stiff wires just closely connected to here. you could just plug this power adapter straight into here, and then that would provide your power into the IoT 2020. It's a little bit rough and ready. You know, you could get a power adapter and have 2 pins directly on here that you could plug in there. What this allows you to do is just leave one of these little adapters there and just unplug it, which is going to be a lot easier. The other option, of course, is to use a 24-volt power supply, DIN rail mountable, like I showed you before, but we wanted to find something that did not involve having somebody to mess around with wiring in mains and having DIN rails and things. As an educational starter kit with the IoT 2020, we want to make it simply plug and play. So here's your power. It's got a nice long lead. You just put that 24 volts in, very similar to what I had on the videos that I first showed you where I made up a panel for the IoT 2020. So that's the power supply for that. Oh, one more thing. So if you're wanting to do this in a DIN rail mount configuration, and I've already shown you power supplies for that, this last device that I have is a switch. Now the nice thing is this is an RS Pro version of an Ethernet switch. It's actually 3 ports. It's got 4 ports in it, but you'll have 1 in, and then of course sharing out to 3 devices. But it's designed to work with a 24-volt power supply as well if you're using a DIN rail mountable one, or even if you're using that power adapter I just showed you. You could jumper the wires from the input to the IoT 2020 from here. You can have a couple of wires just going across to the input of here as well, providing the 24 volts and ground. And this is a nice handy DIN rail mountable switch that can just sit on your DIN rail, and away you go. So if you're mounting everything on a DIN rail, great way to get a little bit of network sharing locally on there. Now there are plenty of other ones that RS have as well. This one is one of their RS Pro range, hardened convenient switch. Now the nice thing too is if you don't want it on the DIN rail right away, you can just undo the 4 screws. It's got some rubber feet and it could just sit on the bench as well. So we'll be looking at this, powering it up, giving it a try in future videos along with the IoT 2020 as well. I think that's everything I have in here from RS relating to the IoT 2020. So the last few items, I'm just pulling them out of the box here so I can get the box out of the way. See if there's anything else in there. Nope, there isn't. Let's just move that. Is relating to my CNC project and things. So let's go have a look at those. So with my CNC project, one of the things that I wanted to do, and a few people commented on it when I built up the first panel for my 4-foot by 4-foot CNC, was that I didn't use ferrules on the CNC for connecting the wires. I just basically neatly twisted the wires together and pushed them into the connectors. So RS has been kind enough to send me a ferrule kit, which I have, which I've shown you in a previous mailbag, but I didn't have a crimp connector available to basically squish them down. So RS have been kind enough, this is an RS Pro version, and I'll be using this for the CNC project to start wiring up the smaller CNC, where you can basically crimp right down to very, very small. I don't know if you can see that easily there. Right, so you've got fully wide there. You can see that you could do a huge range of crimps, and the way that it crimps down on the ferrules, you can go down to a very small crimp connector. It's ratcheted so that you could release your hand as you're going until you get to the pressure, and then you can just release it and it will come back out again. All right, so that will do quite a different range of ferrules, right from 8 gauge right up to 26 gauge basically. Most of the CNC is going to be using 0.5 millimeter cable, which is industrial kind of cable suitable enough for a few amps of power for driving the stepper motors and things like that. So this is going to be very useful for getting those ferrules crimped on, because my previous crimp tools wouldn't handle them because of the style that they are. So now I'm going to be able to do that. So that's a nice crimp tool which we're going to be looking at. Again, it's an RS Pro. I have one of the new Arduino industrial processing modules, microcontrollers. So I haven't opened this up yet. Let's just get inside here. Arduino has a lot of different modules that are available, but technically speaking, none of them are what you would call industrial. So what Arduino has done is released an Arduino that actually does conform to some of the industrial kind of formats and specifications, and this one it's called an Arduino Industrial. It's contains basically everything that an Arduino Yun has, but in a more industrial format, and this is designed to be able to be embedded onto other platforms. But what you have here is basically everything a Yun has. So you've got an Atmel processor over here, which is using your USB interface and can run your Arduino sketches and everything else. But then you also have the Linux portion using, I think it's a Theros. We'll check the specs when we go to review this, which has got built-in Wi-Fi communications and things like that. And then, because it's an industrial style, it does not have a conformal Arduino Uno or Mega footprint for adding expansion to it, but they have provided all the headers and the sockets, and they provided jumpers so that you can hook up the different devices that if you want to for expansion. It's got some screw holes for mounting it into some kind of case, and then you can either solder directly onto these, or you could use jumpers by soldering in some headers and things and jumper off to other boards and stuff like that. So we'll have a look at this. From what I understand, it's basically an industrialized version of an Arduino Yun. You can look up the specifications if you don't want to wait to the video on the Arduino site, and I'll provide a link as well to the RS page that details the specifications and everything for this. So that's an Arduino Industrial 101, I think is the proper name for it. So the last couple of things that I have here is a Raspberry Pi version 3. Sorry, this one's already out of the packaging, which I'm going to use for putting into the Phoenix case and then setting up a DIN rail mount kind of project demonstration, just to show you how you can use this with a Raspberry Pi. And then the last unit, which is going to allow me to communicate via my PC to some devices. This is a small board that plugs into USB on one side, and it's actually an RS485 adapter. So you use a standard USB cable, plug it into here. This is not in a case or anything right now. I might model a 3D printed case or something for it. But it has an FTDI, I think it's FTDI, USB to serial chip on board, and then a MAX 485 or something probably chip to convert it to RS485 signals. Now, one of the really nice things about this is that, yes, it is a FTDI chip on there, is it has a standard RS232 DIN DB9 connector for connecting up to your other devices. So I have a numerous number of industrial PLCs and things like that that have RS485 with a DB9 connection, and I'm always struggling to get my PC to easily communicate with it using a standard COM port, so that I can use Visual Studio or something just to send some test signals, either Modbus or something else, but through RS485. So now that I have this unit, I'm going to be able to get my PC or any application using a standard USB serial to talk to those, and that'll include actually you know, some of the versions of things like the IoT 2020, specifically the IoT 2040, has RS485 ports on it. The Lascar Panel Pilot Ace has RS485. The Barth PLCs have RS485. I mentioned that with the A and B connection on them. So a simple DB9 to just two-wire connection will allow me to communicate to those from a PC, etc. Now, I'm not sure whether this will be recognized by a Raspberry Pi or not, but if it is, then it will also allow me to use things like Node-RED and things to communicate with the Barth and other PLC components as well. So that's going to be very handy to try and integrate into a lot of the projects. And I think that is everything from RS components for the moment. That's everything for RS. I'm going to clean the table now and pull up my other mailbag items. I'm going to do that in a separate video, part 2, and we'll have a look what I've got from other places around the world. Anyway, thank you very much to RS Components. I will provide links to all of these, and there will be videos that will be evaluating and using these and showing you how to use them, because as you know, with my site, it's all about showing you how to use stuff. I'm not really trying to be a marketing channel. I know sometimes it appears that way because I get a lot of things sent to me from RS Components, but it's all about showing you how to use them and figure out how to make them talk to other components and get them up and running and things like that, because I do find a lot of manufacturers are not so good at showing you how to use them beyond a basic blink or some very minimized application or something. So anyway, that's it for this one. Let's close it off and we'll get to part 2 where we look at all the other bits and pieces.